All right, team, 1.4 equations of lines. Here's a little bit more information about our linear functions. We have the general form, ax plus by equals c. Now, here, the a, b, and c are constants, meaning they're just numbers. So remember, x and y are only variables and their exponents are 1. We have the slope-intercept form, which we already talked about in 1.3, for y equals mx plus b. Remember, m represents your slope, b is your y-intercept. We also have the point-slope form, where we have y minus a point, the y-coordinate of a point that's given, equals slope times, in parentheses, x minus the x-coordinate of a point that's given. But here, the x1, y1 is any point on the line. It does not have to be the y-intercept like the form before it. Horizontal lines, remember, go left to right like this. They're flat. And they have an equation where your y value is the same no matter what. So we can say y equals a, some number a, and your slope is 0. We talked about that earlier. Your vertical lines that go up and down, your x values never change. So we can say, x equals a. And those are the slopes that were undefined. Now let's remember parallel and perpendicular lines. Parallel lines look like railroad tracks. Okay, they go in the same direction at the same angle. So the one thing we know about parallel lines is that they have the same slope. Perpendicular lines cross, but they cross making a 90-degree or a right angle. Okay, so a lot of lines cross, but they have to make particularly 90 degrees. In order for them to do that, there are 2 criteria for their slopes. They have to have, first of all, opposite slopes, in other words, opposite signs. And they have to be reciprocals. So for example, if slope of line 1 is a 3, then the slope of the line perpendicular to it, of line 2, has to have the opposite sign. So this one has to be negative, and it has to be the reciprocal of 1/3. So notice they have both the opposite sign and it's flipped reciprocal. So let's review writing linear equations given 2 points on the line. So we want to write the linear equation of the line that passes through the points -3,7 and -6,5. Remember, no matter which equation we use, we need the slope. So the slope, I'm going to subtract my y's. I'm going to start with the 7 this time. 7 minus the 5, those are my y values. -3 minus -6, so that becomes a plus a positive. So I get a 2 on top and a +3 on the bottom. So we have a slope of 2/3. Neither one of those points is the y-intercept. How can we tell? Neither x is 0. So none of those land on any of the axes, as a matter of fact. So we can use the point slope, and we can plug in for any of these y values. Let's just use the first guy here, -3 and 7. So I'm going to plug in a 7 for my y1, 2/3 times x minus a -3 for my x1. Remember, minus a negative is plus a positive. So we get y minus 7 equals, when we distribute that 2/3, we get a 2/3 x plus the 2/3 times 3, we end up with a 2. Add that 7 to both sides. We get y equals 2/3 x plus 9. Now you can also do this using the slope intercept.
form, just be careful not to plug in the 7 or the 5 for your b. Neither one of those is your y-intercept. So let's try that.
So we have y equals mx plus b. So we have y equals a slope of 2/3 x plus b.
And remember, b is the only variable we need to find. X and y represent any point. So we can use that -3 and 7 again.
We could plug in 7 here for the y, -3 for the x. These two reduce. So I'm going to get 7 equals -2 plus b.
If we add the 2 to the other side,
We would get b equals 9, and then we can write our equation. Y equals our slope times x plus our y-intercept,
which is the same thing that we got using the point slope. So oftentimes the point slope's easier, but it really just depends.